All right, so section 7.4, we're going to add and subtract our radical expressions. This first example, we see 7 times square root 3 plus 8 times square root 3 minus square root 3. Now, as you're adding and subtracting these radical expressions, I want you to look at these the same way you would if this were 7x plus 8x minus x. So the x term, or the variable, you would treat it the same way you would the root. As long as your terms have the same root, square root 3 underneath, then you can combine them. They're considered like terms. So in this case, the 7 times square root 3 plus 8 times square root 3 minus 1, we want to see this as being 1 square root 3. We can combine those terms. So we just add 7 plus 8 minus the 1, and that'll give us 14. Square root 3. You keep the square root 3 at the end. For example 2, we have the cubed root of 11, 8 times the cubed root of 11, plus 15 times the cubed root of 11. Now both of these terms have cube root 11 behind them, so we can combine. 8 plus 15 gives us 23, and that's times the cube root of 11. And that's our answer. They're considered like terms. If you have the same root, the same number underneath that root, you can combine them, add or subtract. In the third example, we see 2 times the square root of 63 plus 9 times the square root of 7. Now we notice here we have square roots, but underneath the first term, the square root, we have 63. And underneath the second one, we have 7. Now this 63 can be simplified. We can divide 63 by a perfect square number. 63 can be divided by 9. 9 times 7 is what gives us 63. Now since 9 is a perfect square, we can take that square root of 9, which gives us 3, and we multiply it by the 2 that was already outside of the square root symbol. 2 times 3 will give us 6 on the outside, and notice we keep that square root 7 underneath. After we simplify, we see the like terms. Both terms have square root 7. So we can add them. 6 plus 9 gives us 15 square root 7. You first want to simplify, find the largest perfect square number that can be divided into 63, and then you can combine the like terms. All right, in this example, you see a similar scenario, 27 and 3. These are two different numbers underneath square root. We can simplify this 27 because 9 again can be divided into 27. 9 times 3 is what gives us 27. We know the square root of 9 is 3. So we place 3 on the outside of the square root symbol. You keep the 3 underneath. You have 3 square root 3 minus 2 square root 3. 3 minus 2 gives you 1 square root 3, which is the same as just square root 3. And that's your answer. All right, in the next example, we see a full expression underneath that square root symbol. So you have 20x plus 20 plus, and then we have the square root here of 5x plus 5. Now this 20x plus 20, we can simplify this a little bit more because the perfect square, 4, can be factored from both of these terms. We can factor 4 from 20 and 4 from 20 again. So when we factor 4 from 20x, we get 5x. And when we factor 4 from 20, we get 5 underneath. Now you see the similar terms underneath the square root symbol. But we calculate the square root of 4. We bring that outside of the square root symbol. The square root of 4 is 2. Now we have 2 times the square root of 5x plus 5 plus 1 times the square root of 5x plus 5. So 2 plus 1 gives us 3 times square root 5x plus 5. Now in the next example, you'll see the square root of 7 outside parentheses. We have to distribute here. We got to distribute the square root of 7 times 3. That gives us 3 square root 7. And then the square root of 7 times the square root of 7 with a minus here. So that will be minus square root of 7 times 7 of 49. The square root of 49 is just 7. And we can't simplify that 7 underneath the square root any further. 7 is prime. So this would be our answer. 3 square root 7 minus 7. All right, in the next example, we will distribute again using our FOIL method. So first terms, 8 times 8 gives us 64. The outer terms, 8 times minus square root 7, that gives us minus 8 square root, 8 times minus square root 10, that gives us minus 8 square root 10. And now the inner terms, we'll get 8, that's plus 8 times the square root 10. And then the last term, square root 10 times minus square root 10, that gives us minus square root 100. Now the minus 8 square root 10 and the plus 8 square root 10, those terms cancel each other out, leaving 64 minus square root of 100. But the square root of 100 is 10. So we subtract 64 minus 10 to get our answer, 54. And then this next example, we're going to FOIL again. The square root of 2x times the square root of 2x. That's 2 times 2 gives us 4. X times x gives us x squared. So the square root of 4x squared. And now the outer terms. That's negative 3 times the square root of 2x. So negative 3 square root 2x. The inner terms, 3 square root 2x. So 3 times the square root of 2x. And then the last terms, 3 times minus 3 gives us minus 9. The negative 3 square root 2x plus 3 square root 2x, those two cancel each other out. And we're left with the square root of 4x squared minus 9. Now we can take the square root of 4x squared. Square root of 4 is 2, and the square root of x squared is x. So here's our answer, 2x minus 9. All right, let's look at some more of the examples where you have to FOIL. So our first terms, outside, notice we're multiplying the terms that are outside together, and then we're multiplying the terms that are underneath the square root symbol. So outside of the square root symbol, 3 times 3 gives us 9. We keep it outside. Inside the square, or underneath the square root, we see x times x. That gives us x squared. We keep that term underneath the square root. So it's 9 times the square root of x squared. That's our first term. Now our outer terms, that 3 square root x times minus square root y. You see what's underneath the square root symbol, x and y. So we'll be minus 3 on the outside. Underneath the square root, we have x times y. So it's minus 3 times the square root of xy. Our inner terms, very similar. We have 3 on the outside. It's positive this time. So plus 3 times the square root of x, y. We just list them alphabetically with our x first. And then the last terms is positive square root y times minus square root y. That's 2 y's underneath, y times y. And we leave that y squared underneath the square root symbol. So it's minus square root y squared. Negative 3 square root xy plus 3 square root xy. Those two cancel. And 9 times the square root of x squared. And 9 stayed on the outside. And the square root of x squared is x. So we have 9x. Minus, here, the square root of y squared is y. So our answer is 9x minus y. All right, so when it comes to dividing terms that have a square root in the denominator, you want to rationalize that denominator. What that means is that we want to remove any square root symbols from the denominator. And the way we get rid of a square root, the way we simplify it, if we had the square root of 2, is we multiply that term by itself. So the square root of 2 times the square root of 2, for example, we'll get 2 times 2 underneath that square root symbol, which is 4. And the square root of 4, we know, is 2. So that happens no matter what the number is. If this were the square root of 4, how will we rationalize that? We will multiply by the square root of 4, because 4 times 4 gives you 16, and the square root of 16 is 4. So in order to rationalize this denominator, we have 2 square root 7. We got to get rid of this square root symbol in the denominator. Is we're going to multiply that square root 7 times square root 7. And whatever you multiply the denominator by, you must also multiply the numerator by. So square root 7 over square root 7. In the denominators, we have square root 49. 7 times 7 gives you 49. In the numerator, we have 2 outside. That 2 stays on the outside, times the square root 7. We can simplify this denominator. The square root of 49 is 7. In the numerator, we keep the 2 square root 7. That stays the same because 7 is prime. We can't divide any number into 7 other than 1 and itself. So the answer would be 2 square root 7 divided by 7. In this next example, we have 8 divided by square root 2. Again, we got to rationalize this denominator. So we're going to multiply the denominator and the numerator by the square root of 2. In the denominator, square root 2 times square root 2 gives you square root 4. And the square root of 4 is 2. In the numerator, however, 8 times square root 2 gives us 8 square root 2. So 8 square root 2, we would carry that over. Now, remember in the denominator, our square root of 4 gave us 2. So this 2 can be divided into the 8 to give us 4. That's our answer, 4 square root 2. Now, we notice something a little different in this third example, where not only do we have a square root in the denominator, but we have a number outside of that square root symbol. We still focus on the square root. We're trying to rationalize by removing the square root symbol. So we're multiplying the numerator and the denominator by the square root of 5. And in the denominator, we have 3 outside, and the square root of 5 times the square root of 5, that gives us 25. So 3 times the square root of 25. However, we know the square root of 25, it's 5. Times the 3 outside, that gives us 15, right? Okay, you can look at it this way, or you can keep the factors there, because look what happens in the numerator. We have 5 times the square root of 5, that gives us 5 square root 5. that 5 square root 5 can be simplified with that 15 in the denominator, because 5 can be divided into 15, leaving 3. Or you can see those 5s, that factor of 5 cancels, leaving 3 in the denominator. In the numerator, you keep the square root of 5. This is your answer. Square root 5 divided by 3. All right, so that's the last example from your 7374 notes. Does anyone have any questions about rationalizing the denominator or adding and subtracting roots, multiplying using your FOIL method? Any questions about these? Don't forget that your homework that's due this week, you have 7-1 through 7-4 homework assignments that are due by November 15th. That's on Sunday. If you guys don't have any questions, that concludes our notes for today. Have a good day and a good weekend. Be safe, and we'll see you on Tuesday of next week.
Thank you.
You're welcome, guys.